Hello, it's Keith here, and this is lesson 20 of the Suck Hunt series of Z80 programming tutorials. You can see Suck Hunt loading up over there, and what we're going to be doing today is we're going to be looking at some more of the code. We're going to be looking at the music driver, we're going to be looking at the title screen and introduction that you just saw, and we're going to be discussing the palette code. So we're going to be going over those sections of the game today. So let's not hang around, let's go over to the source code and let's take a look. Okay, so here's the source code, and we're going to be looking at those parts today. So the first thing is the sound driver. Now, we are using Interrupt Mode 1, but the MSX, the way this game runs from a cartridge, and so the way the cartridge is set up, the first 0 to 3 FFF range is all ROM. So the Interrupt Mode 1 interrupt handler at 0038 we can't write to, but what we can do is we can patch into the firmware's interrupt handler, which actually is fairly adequate for us. This isn't really possible on the Spectrum, but on the MSX it's very easy. All we need to do is we need to patch into memory address FD9A, and we're putting in a jump command there, C3 as a jump, and then we put the address of our own interrupt handler, and that will basically run as part of the firmware interrupt sequence. So if we just have a look, our interrupt handler is very simple here. We are just running the play command of Arcos Tracker. This is Arcos Tracker 1. It's a modified version of Arcos Tracker 1 rather. I modified it. It works from ROM and it's slightly smaller and more limited, so that's what we're using. It does use all of the registers, including the shadow registers though, so there's no point switching into shadow registers because we're going to use those as well. But what we're doing here is we're backing up all of the registers and restoring them there so that our music driver doesn't cause any trouble. So that's what we're doing, and then we're returning, and this actually returns to the ROM interrupt handler, so you'll notice there's no enabling of interrupts once we return. So that's how we're patching in and getting our music playing, which of course is quite important. So that's the music handler. How about the introduction sequence? Well, once we've got all of our graphics loaded into memory, then the first thing we're doing is we're actually changing the music, and we're changing to the intro song. What this does is it copies the introduction song into an area of RAM which is designated as the place that the Arcos Tracker will play from. My minimal Arcos Tracker always plays from the same memory address every time. But then what we do is we use an animation list, which is a script which defines the sequence of the animation. Now, you saw the title sequence a moment ago. There were basically 4 animations in the corners, and there's 2 frames for each of the corners, and we can see that scripted just here. So we've got 2 frames of animation. There's the first 2, second 2, third 2 and fourth 2. The numbers are out of order because I originally did them in the wrong order, so never mind. We're specifying the X and Y coordinate, and then there's a byte for the colours because there are 2 possible colours. Some of them are the pink and some of them are the blue. So that's why we've got a byte there. And by doing this, basically the entire sequence is a loop of 4 stages of animation, and everything is defined by this animation list. Now, the actual tiles themselves and the graphics, these are done as 8 pixel by 4 pixel tiles, and they're double heighted, so each line is drawn twice to the screen. This was for the Amstrad CPC. There wasn't enough memory left, so I halved the amount of memory by simply halving the height of the tiles and padding them out. The introduction's only shown very quickly, so it's unlikely anyone's going to notice. But here are the frames of animation. So there's the first frame, and there's the second frame, and so on. So those are what we will actually be passing to our tile drawing routines to show the introduction animation. So we're clearing the screen here, and then what we're doing is we're loading in the specification of this frame of animation. IX points to the animation sequence, and we're getting the X and Y position here. We're loading the X and Y position. We're then loading the address of the first tile map. We're then going to show that. So what we're doing here is we are showing the tile map. We're using this quarter routine. The quarter routine is because it's a quarter of the screen the tile map covers. We're then loading in the color, and we're doing the fade in. We're then loading in the second frame of animation, and we're showing that second tile map over the first. Of course, this is already faded in, so we can now see what's happening. We then wait a while, and we do the fade out in the same color. We then move to the next sequence of animation, and we're then just repeating. We're using B as a repeat counter, and we are repeating 4 times. So that will show the introduction animation. Now, the final part of the introduction animation is to show the title screen and then to play the speech message, but the speech message only shows after the introduction. The speech message says Operation Suck. It's a parody of the Operation Wolf introduction, so if we didn't show the Operation Wolf introduction, then we don't play the speech, and so we use the accumulator to decide whether we're going to play the speech or not. So 1 is yes. Now we're going to go over the game code next time, but what we're going to look at finally here is the palette code. So the palette code is handling the 3D effects and also the fading. Let's find those palettes. Here they are. So there's basically 4 possible palettes. There's the 2D palette here, which has got the first 4 colors in grey and the rest of the colors are black here, and you can see this is also used for the blackout mode. We've then got the red cyan palette. This is for red cyan 3D glasses. We've got green and magenta, and we've got yellow blue here. So we've got all the possible options, and the final one is the special one for the title screen, and you can see each set of 4 colors has been set to the same color, and this effectively hides one of the eyes. So that's what we're doing there. Those are the palettes. Now when we want to use one of these palettes, the sequence is fairly straightforward. All we're doing here is we are loading in the palette number. We are then shifting the palette number, effectively multiplying it by 32 because there's 16 colors and 2 bytes per color. We're then loading in the bytes from the palette here, and we're going to out them to the palette port here. So that will actually set the colors. So that's what we're doing to set the colors. Now this version will set 16 colors, but sometimes we want to just set 4. And these are used for the fades. You see, the fades aren't defined as a full 16 color set. They're defined as 4 colors and 4 separate stages of fade. And so we're only fading in 4 colors, and these are basically multiplied up for all the 4 possible combinations of the 2 eyes. So when we use these fades, what we're doing is we've got this do fade in routine. It loads the 2 possible palettes into HL and DE, and it will swap them around depending on the accumulator, and that's because we load the accumulator with the palette when we're doing that introduction sequence. And so what this will do is it will use the palette that's pointed to for first setting the first 4 colors, and then because we're backing up and restoring HL here, those same 4 colors are used for the remaining 12 colors. We then pause a while and repeat. This effectively causes the fade and the 4 possible stages of the fade. That's how we're doing that fading in effect. So that's the palettes. We've also got the code that handles the 3D. The 3D mode code here, you can see it here. It's pretty straightforward. We've got 3 possible 3D depths, and this is used as part of the sprite routines to change the offset between the 2 eyes, which makes the 3D effect more and less extreme. If we want to turn on or turn off 3D mode, we're using this byte here, current mode 3D, which is in RAM, and we set that to either 1 or 0 to turn the 3D on or off. Now on the other systems, the ones that ran from RAM, we were using self-modifying code to do that, but because this system runs from ROM, we can't do that, so we're not doing that. So we're just using a variable. Anyway, that's all we're covering today. So next time we're going to be going over the code that handles the actual main loop. We're going to look at the main loop code, and then we will finish covering this version of the game. As I say always, you can go to my website, you can download the game, you can also download the source code, and you're welcome to make any use of any part of the source code in any way you can. Even if you somehow manage to make money out of it, you can do it commercially, I really don't care. Anyway, if you want to support my content, then you can buy my book. It's called Learn Multi-Platform Assembly with Chibi Akumas. It covers Z80, 6502, 68000, 8086 and ARM. It's doing very well, actually. It's available on Amazon. Should say that, shouldn't I? It's doing very well, so you can be pretty certain there will be another book sometime in the future. In about a year's time at this point, I'm planning to do a second book which will cover more CPU types. If you don't want the book, you can also support me on Patreon. You can see my Patreon backers who very kindly allow me to keep making all of these silly games and spending all this time making the content. Anyway, hope you've enjoyed this today. Thanks for watching, and goodbye.